Welcome everyone. So this is the Astable multivibrator that is used to make a flasher, police flasher LED, and you can see there are two BC107 transistors. These are the metal transistors 1 and 2, and there are two capacitors, and there are resistors and two LEDs. So these are the materials that you require: two LEDs, transistor BC107, and resistor 4.7 kilo ohm and 82 kilo ohm and 280 ohm, and the capacitor 222 microfarad, and then you require a 9-volt DC supply and a PCB or a breadboard. So this is the circuit that I have used here. You can see these are the two transistors Q1 and Q2, whose emitters are grounded, and this is the collector resistor RC1 of the transistor Q1, and this is the collector resistor of transistor Q2, and this is RB1 and RB2, that are the base resistors of transistor Q1 and Q2, and C1 C2 are the two coupling capacitors of transistor Q1 and Q2, and the 9-volt supply is given through here, and this is the resistor that is used to limit the current through the LEDs, and the same value of resistor is used for the other LEDs, and you can see the output is taken from both the collector terminals of the transistor Q1 and Q2, and you can see the base of the transistor Q1, that is capacitively coupled through the coupling capacitor C2, and the base of transistor Q2 is capacitively coupled by the capacitor C1, and this is the theory. So in theory part, I have assumed that R1 equal to R2 equal to R, and C1 equal to C2 is equal to C, and our R1, R2 and C1, C2 are the resistor value and capacitor values. So here I have taken that C1, that is capacitor C1, and C2 both is equal to 22 microfarad, and I have designed this Astable multivibrator for T on, that is time for on of transistor. The transistor turns on for 1 second and turns off for 1 second, so total time period is 2 seconds, and this is the equation that is used to find the resistance and the capacitance value. Capacitance value we have assumed 22 microfarad, so T1 is equal to 0.69 R1 C1, that is T1 means the turn on or turn off time of the transistor 1 Q1, that is Q for Q1. Here T on and T off are 1 seconds, so T1 is equal to 0.69 R1 C1, and we find the value of resistance R1, which is nothing but the base of the resistor RB1, that is this is the resistor R1, or you can say that RB1, or you can also say R1 R2, and the value of resistance R1 is equal to T1 by 0.69 into C1. T1 is 1 second, it's equal to 0.69 and 22 microfarad, which we get that on solving this we get about 65 kilo ohm, and I have used here 82 kilo ohm. So if you use 65 kilo ohm, you will get the time period accurately. This also you will get accurate, about almost accurate. So similarly we can find the T2 value. T2 is equal to 0.69 R2 into C2, and R2 is equal to, which is nothing but RB2, that is the base resistor of transistor Q2, which is equal to T2 by 0.69 C2, and it will also be equal to 82 kilo ohm, and this is the equation for finding the resistance value for the capacitor resistor RC for both the transistor Q1 and Q2. that is RC equal to VCC minus VC saturation by IC, where VCC is the supply voltage that we are giving, that is 9 volt, and VC saturation is the saturation voltage for the transistor, that is about 0.6 volt, and IC is the collector current for the transistor BC107, that is about 2 milliampere. On solving it, we at about 4.2 kilo ohm. I have used 4.7 kilo ohm standard. It is 4.7. So these are the materials required, and this is the theory part. And I have made this on a small breadboard. You can see this. On this top I have marked positive and the bottom part negative. And these are the two resistors. And as you can see, both the emitters of the transistors are grounded. That is, as you can see here, it is grounded for both the transistor Q1 and Q2. That is done through these wires. So firstly you have to make this place these transistors Q1 and Q2 very close to each other, and then you can place other parts. You can place the resistors and capacitors exactly as shown in here. So if you I have done a breadboard, so it will be very difficult to place it on a small cars or on bikes. So you can also use a PCB. I have mentioned here. So if you use PCB, you will require very small space, and you can make this small circuit. So you can see the light police flasher LEDs. The LEDs get flashes exactly like police cars. But after when we connect this, we give 9 volt supply. You can see that the thing you should take care of is that as you have seen that there is a chance of this two resistors getting connected or through the metal gap. So you should be very careful with that. You can see you shouldn't leave exactly required space. So now I will connect this 9 volt supply to this breadboard. As you can see, immediately after connecting the supply, the Astable multivibrator starts working. The LEDs turns on for 1 second and turns off for another 1 second. I have designed for 1 second delay, and you can see that it flashes like police flash car, and you can see the time period. You can check out the time period by removing any one of the resistor. Here I am removing this red one. So you can see that the LED that is flashes for 1 second and turns off on for 1 second and turns off for 1 second. So the total time period is about 2 seconds. Now I will connect the red one. So you can see now I will switch off the light so that you can see it more brightly. This is the small this is very cheap circuit, and you can easily mount it on a PCB so that you can use in your motor bicycle or any cars. And you can also increase the number of LEDs, but you should take care of that one thing. So if you are increasing the number of LEDs, means then you have to reduce this resistor. Actually this resistor is about 280 ohm that I have used here. 280 ohm, that is used to limit the current through this LED. So if you decrease this value of resistor, then you can increase the value of number of LEDs, so that you will get more brighter image. Now if you put with this 280 ohm another LED, the intensity will become very less. So now the time period is 1 second, and you can decrease or increase the time period based on this resistor and this on this RC resistor and this capacitance that you can see over here. So now I have assumed for 22 microfarad. Now if you change the value of capacitor, you will get much smaller or bigger resistor. You can make the time period 1 seconds or 0.5 seconds or 0.001 second as your wish, so that it becomes more the Astable multivibrator makes more transitions faster, that is from one stable state to another stable state. We can increase the stable states time by varying the value of capacitors and resistors. I hope all of you will enjoy this, and this is very cheap to make. Thank you.